So welcome everybody to MLQ 2021. I'm Christian Bonato from Heriot-Watt University, one of the co-organizers of this conference, and I'm just going to give a brief introduction about what the conference is about and some practicalities. Of course, I'm going to extend also the welcoming to you by the other organizers, Raffaele Santagati, Natalia Ares, Srinivasan Arunachalam, Fedor Yelesco, and Nathan Wiebe. So before I start, I'd like to thank a few people that have made this conference possible. First of all, our two sponsors, Quantum Machines and NVIDIA. So both Quantum Machines and NVIDIA have given us funding that allowed us to pay for the bills of this conference and to actually make it happen. They're both making devices that help the research field we're interested in, and you're going to hear two industry talks from them in the next days. Also, this conference was only possible due to the work of quite a lot of people behind the scenes, in particular Sarah Nutt from Heriot-Watt, who's been taking care of the administration work. And then a quite large team of PhD students and postdocs from all our. In particular, let me thank Timo Joas and Christian Becker, who've been really making a great effort in managing all the technical platforms and the organization. So what is MLQ 2021? Let me first start by what this conference is not. So MLQ 2021 is not a conference about quantum machine learning. So our goal is instead slightly different. This is a conference when we want to look at how classical machine learning, so learning and statistical technologies which are already available, can help address the bottlenecks we currently face in quantum technology. There are a couple of talks about quantum machine learning, but again, that's just a small part of a broader effort we are interested in. Another important point is that MLQ is multidisciplinary. So we have a collaboration between physicists, electrical engineers, computer scientists, statisticians. So we have a very diverse background of attendees and speakers. And it is a challenge for the speakers to make sure that they deliver their talks in a way that is accessible by this wide range of backgrounds. Also, MLQ is platform agnostic, so we don't focus on a single quantum tech platform. But we want to discuss themes which are relevant for all quantum technology platforms which are currently being developed. As you have seen, the conference is centered around three questions. This is because quantum technology is, of course, a very big field, and it will be unthinkable to cover it all in just a few days. So we decided to focus on three specific, but at the same time, relatively broad questions. The first one is that recently, researchers have managed to build tiny quantum sensors with enhanced sensitivity and very high spatial resolution, which have been applied to study bigger and bigger systems. And so the question now is, how do we optimize the way we extract information from our measurements? And how can we minimize the number of measurements we make? So this is quite important technologically. And you can think, for example, about adaptive schemes like the one represented in this Nature News and Views by Stephen Bartlett. So this leads to the first question: how can a quantum sensor optimally extract information about its environment? A second topic is that recently we've been able to achieve control over a few tens of qubits in the quantum supremacy paper recently demonstrated by Google. But of course, each of these qubits has several tuning knobs that need to be optimized and controlled very carefully. And so you can imagine that with a few tens of qubits, you already have a pretty big parameter space to explore. And then an open question is, how can we tune control knobs and make sure we can scale these systems up? Which is the core of our second question: how can we achieve fully automatic calibration and operation of multi-qubit circuits? Finally, the fact that we can implement a few tens of qubits means that gives us a way to start performing quantum simulation of chemical systems on meaningful scales. And so the question is, how can we use machine learning to approximate ground state and mitigate noise scale quantum experiments? So question 3 is, how can machine learning improve the performance of quantum algorithms for quantum chemistry? So the nice thing is that I just took all these names from the speakers' talks, or some of them at least, and you can see there's quite a big toolbox of methods, methodologies, and strategies we can use. We can take from machine learning, from statistics, from signal processing, and try to apply to quantum information and quantum technology more in general. And so over the next few days, you will hear a bit about all these different tools, and hopefully they will give you some inspiration. So the conference will last 5 days. We will have tutorials, invited talks, and contributed talks. Tutorials will be 1 hour long, and there will be 3 minutes for questions and discussions. So this means that there is plenty of time for you to ask questions. So please do it in the Q&A. And it's a big chance to have world-leading speakers here for half an hour to reply your doubts and give you feedback. So the goal of the tutorials is twofold. On one hand, we would like to use the tutorials as a way to bring all the different background of the communities that we target up to speed. So we have physicists, but we have also computer scientists, and we want that both at least have a grasp of what we are going to discuss. The second goal of the tutorial is that they will pose the open questions in quantum technology that then machine learning will address in the next contributed and invited talks. So here you see photos of all our tutorial speakers. Again, is leaders in their fields, and so you have listened to them and asked them questions. Just as to summarize, for question 2, we have a tutorial right after my introduction about nitrogen vacancy centers in Diamond, which are a prime system for quantum sensing. And it will discuss the physics and what are the needs in terms of optimization and learning. And then there will be a second tutorial about parameter estimation, so more on the statistics. Tomorrow we'll hear an introduction to quantum computing in the more targeted on superconducting qubits, followed by a computer science tutorial on how we can automatically tune parameters via heuristic search. Finally, for question 3, we'll have a tutorial on the basics of quantum chemistry and material design, followed by a second tutorial on one particular quantum algorithm which has been widely applied in quantum chemistry, which is the variational quantum eigensolver. For invited talks, we have 3 for each question. They are 30 minutes long and 10 minutes for questions and discussions. Contributed talk, there will be 17 minutes long with 5 minutes for questions and discussion. Contributed talks for question 1, 6 for question 2, and 3 for question 3. So again, as I mentioned in the introduction, we have 2 sponsors which have provided funding and support for this conference. You will hear Jonathan Cohen from Quantum Machines discuss their quantum orchestration platform on Thursday, the 4th of March. And then you will hear Asher Fredman from Vidya on Tuesday, 2nd of March. We'll also have a poster session tomorrow, Tuesday at 3:30 GMT. The poster session is a bit different than in other conferences because we have video posters which last less than 20 seconds each. We have 20 of them. You can see here a few snapshots of the nice work that our students have done. Students and also researchers. There will be, so the poster prize will be announced at the end of the conference on Friday. And a few details, so the poster session will be held on GetterTown. You have received a link in your emails. So you will find, when you enter, you will find a map and you can move around with your mouse and your keyboard. When you get close to somebody else's avatar, you can connect and discuss. Again, we will send more information via email, including the password to enter GetterTown tomorrow. So a couple of practicalities. First of all, there's a live Q&A during talks. So since we have quite a lot of attendees, we won't give people the opportunity to speak because it will be a bit of a mess, but you're welcome to type questions in the Q&A chat. The session chair will ask then the questions to the speaker. If for lack of time, all questions can't be answered, then we will post the remaining questions on Slack for the speakers to reply later in their own time. And as I just mentioned, you received all our Slack link, so you can also type questions there, and the speaker will reply as soon as possible. And I mean, of course, all our speakers are successful and active scientists, so they're busy people. So please be patient sooner or later, but yeah, just don't stress, don't harass them. So in terms of attendees, we have 750 registered attendees, which is quite surprising also for us organizer, I would say. So I hope a good fraction of them shows up and participates to the conference. Quite all of the world is represented. So you see quite maybe half of our attendees are from Europe, mostly Germany and Great Britain, but a few from essentially each country. We have quite a large attendee base in North America, in India. In terms of background, so let's say 60% of the attendees work on quantum physics, but there's still a 40% that are not working on quantum physics. And I'm quite proud of this because that means that we are reaching our goal to try to bring different communities together. So there's like a 20% of computer science, some math, some electrical engineering, some other areas of physics. Also, this conference is quite diverse in terms of the expertise level of the attendees. There's 20% of professors, maybe 30% of PhD students, postdocs, quite a significant fraction of people from industry, and quite a significant share of undergraduate students. So I hope all of them can enjoy the talks and the tutorials. Just to finish, a couple of more things. So please do not share Zoom links. This conference is free and we welcome everybody to attend, but we want to keep the number of Zoom licenses under control. So the correct way to do it is not to give the link to a friend that also wants to join, but just tell them, please register on the website. They'll get accepted, no questions asked, and they'll get their own link. So we can know more or less how many people are going to follow. Second thing, talks will be recorded if the speaker agrees. So many of them will, some will not, for different reasons. Even if the talks are recorded, we still think it's good to attend live and ask questions if possible. Of course, we understand that for some people in some geographical areas, some talks will be late at night, so no problem with that. But if you can, please do attend live. So with this, I would just like to wish you all the best for the conference. Nice attendees. Let's try to make the best out of this and make it a great event. Thank you very much. So I see there are 2 questions on the Q&A before I pass the word. So about YouTube, so some talks will be posted on YouTube, not all of them. So, and then somebody is asking if we will discuss the applications to particle physics. So the answer of this is unfortunately not, because we will just focus on the machine learning application for the 3 specific questions in quantum technology that we specified as part of the conference. So thanks again, and then I'll pass the word to Fedor, who's going to chair the first session.